Okay, this assignment's a real treat. First off, one thing that's going to make it go a heck of a lot quicker is if you know how to deal with a negative exponent the quick way, okay? Not making all those boxes and all that stuff, okay? Okay, 4 to the second means 4 times itself, that's 16. Now, if you have a negative power and you'd really rather have it be positive, you could put a 1 over it, make it positive. And then 4 to the second, 16, so it's actually 1/16. Now compare that to that, it's just the reciprocal, okay? 16, 4 to the second, 16, 4 to the negative second's 1 over 16. Now you can do this one, I know it's a fraction, you don't have to be a rocket science to do a fraction to the second power. What's 1 times itself? 1. What's 2 times itself? 4. Now I would rather have that not be a negative. I'd like it to be positive. Well, I can do that if I make it positive and then flip that to 2 over 1. So what's 2 times itself? 4. What's 1 times itself? 1. 4 over 1's 4 though. So again, when I have a negative power, it's really just a positive power reciprocated or flipped. Okay. All right, I gotta get a blank piece of paper here. That was the master I was using. Okay, now you're graphing exponent functions, but it is going to get a little more intense. You have to do the domain and range here today. This one's an easy one. It's kind of like the one we had in the last assignment. Okay, so it's 4 to the power of x. Okay. So the base is 4, the exponent's x, it's really the only thing I have. So I make that table where I do 2, 1, 0, negative 1, negative 2. And anytime the independent variable that I'm going to put numbers in for is an exponent, you need that asymptote, ASY. You can abbreviate it on your own, that's fine. And it always starts at 0. So 4 to the second, what's 4 times itself? 16. So I know that that's 1 over 16. 4 to the first is 4, so I know that the negative first would give me a 1 over 4. And anything to the 0 is 1. There's no outside, so this is what I graph. Okay? So 2/16. Well, I'd have to go by 2's to get to 16. So 1, 2, 2, 4, 6, 8, 10, 12, 14, 16. Now, after you graph the first point today, I want you to label your asymptote. Y is 0 is just right in the middle, okay? All right, so we can't cross that line. So 1, 4, 2, 4. And with the fractions, all they do is get closer to 0. They get infinitely smaller. Now, domain and range. Well, the domain's easy. When you have arrows on both ends of the graph, the domain is all. There's no cutoff side that way. But there is going to be a range, okay? And the range is your asymptote. So y is 0 is that way. And all points are above. But you're not going to put the line because it never actually equals 0. It's just above it and it gets infinitely closer but never actually touches it. Okay, that one wasn't too bad, but here's the next one, as you can see. Make your table, don't give a lot of room here because now all these operators I ignore except the 2 to the x power, okay? So 2, 1, 0, negative 1, negative 2. Okay, what's 2 to the second? 4, that'd be 1/4. 2 to the first is 2, that'd be 1 over 2, and then 1, okay? And you also got to remember, when that independent variable is an exponent, you are going to have an asymptote, and it always starts out at 0, okay? Now, you're not going to adjust the x's because on this one, because it's just the x power is just by itself. The +2 after it's not part of the power. There are going to be some problems where you have an x power, then there's a -3 or a plus something after it. But this is not one of those problems, so I leave the x's alone. Now, you also have a times -4 and a +2. So you need to do those operations to all your y's, and you also have to do the operation to the asymptote. Okay, that also changes our asymptote, which then adjusts our range. So I take 4 times negative 4 is negative 16, and then negative 14. 2 times negative 2 plus 2 is going to be negative 6. 1 times negative 4 plus 2 is negative 2. 1/2 times negative 4 plus 2 is actually going to be 0. 1/4 times negative 4 plus 2 is 1. Now this is what I'm going to graph. Okay, that's the actual function. Again, I had my parent function at y equals 2 to the x, and then I just transformed it with the outside. Okay, so 2 negative 14. Also, you'd start graphing at your most extreme, negative 14. You would have to go by 2's. Okay. Oh, I forgot. You also need to times by negative 4 and add 2. Well, 0 times negative 4 is 0, but when you add 2, it's 2. So the times doesn't do anything, but now the asymptote goes to 2. So 2 negative 14, you're going down by 2, 4, 6, 8, 10, 12, 14. 1 negative, and then after that first point's graphed, after the most extreme point's graphed, plot your asymptote. But now it's 2. So I go to where 2's at on the y. Now keep in mind, since I'm going by 2's, 2 would be there on y, and now that's where the asymptote line's at. Okay? Now plot the rest. 1 negative 6, 2, 4, 6, 0 negative 2, negative 1, 0. Keep in mind you're going by 2's, so negative, and then all you do, really after you graph the first 3 points, the other 2 just get closer to the line and you know how to graph it. Okay, you don't even really need to plot those other 2. Okay, so the domain's all. Okay, the range, you got y and 2, but this time they're all below. And 2 won't be touched, so I don't put the equals, just that. Okay, next problem. Again, here's my exponent x, and the base is 1/3. So I don't need to transform it after I get the original, because there's no outside operations. Okay, so 2, 1, 0, negative 1, negative 2. Now you have a fraction, so what's 1 times itself? That would be 1. 3 times itself is 9. So if that's 1/9, this is 9. 1 to the first that's just 1/3. So this is 3 and this is 1, okay, in the middle. You don't have to transform the function because there's no outside operations like there was, okay? All right, so we just need a graph. Now don't forget the asymptote. It always starts at 0, okay? And it's going to stay at 0 because we're not going to transform it at all, like I did on that last one. There's no outside operations that would transform it. So I'd want to start graphing here, okay, with the negative 2, 9. And I can make it by 1s if I go there. So negative 2, and then 9's up at the top. Negative 1, 3. 0, 1, and then I can see what's going to happen. And the asymptote's at 0, which is that middle line. You just never cross it. Okay, so the domain is all. The range is not all. It's y at 0, okay? And you're above it. Okay, so y has to be greater than 0, not equal to it though. Okay, next problem. Again, the x means you're going to have an asymptote. I forgot the domain and range. Just put d and r down there. Okay. That asymptote always starts out at 0. Y equals 0. Okay, here's the x is a power. Its base is a half. Just focus on that part of it. Okay. So 1/2 to the second, well, what's 1 to the second? 1. What's 2 to the second? 4. So that would be 4. 1/2 to the first is 1/2, that would be 2. And then that's 1. okay? Now your x stays the same because there's nothing else with that exponent other than x. But the y's you have to transform. You have to multiply them all by -2 and then -3. In that order, you do the times first. And also you have to do the same thing with your asymptote or you're going to be up a creek there. So I'll just do my asymptote first so I don't forget it. So what's 0 times -2? That'd be 0 minus 3 takes it to -3. And then I do the operations, okay? 1/4 times -2 minus 3 is going to be -3.5. Okay, 1/2 times -2 minus 3 is going to be -4. 1 times -2 minus 3, that's going to be -5. 2 times -2 minus 3 is -7. 4 times -2 minus 3 is -11. So I would want to start graphing down here where the fractions are not, okay? So I'd have to go by 2's, but you're going down, keep in mind. So -2, 2, 4, 6, 8, 10, 11. After the first point's graph, set your asymptote at -3. So remember you're going by 2's, so -3 is here on the y-axis. Then I just make a horizontal asymptote right there. 1, -4, 1, 2, 3, 4. 0, -5. Or no, -1, -7 is what I should have graphed after that. My bad. -1, 1, 2, 3, 4, 5, 6, 7. Sorry about that. 0, -5. Or no, remember, oh shoot, sorry, that's not my best work on this problem. Okay, you got to go by 2's. So -2, -11, okay, is right there. I had it right the first time, okay. -1, -7, 2, 4, 6, 7. I forgot I was going by 2's, that's why that was 0, -5, 2, 4, 5, and it's these 3 points, and once you get 3 of them down, you're good, okay. So domain is all, because the arrows go on each end. There's no cutoff that way, but there is a cutoff this way. So -3, and you're below it, so it's less than -3. Sorry about that problem. That wasn't a good explanation because I was all over the place. Okay, next one, make your table x, y, okay, 2, 1, 0, -1, -2, and the asymptote starts at 0 for the y. Now, again, that's a lot of stuff right there, but look at your x and look at its base. Just focus on that part of it when figuring out your y's to begin with. 1/4 to the x. Also cut off the +1 that's with the x. Just cut it off. And actually, when I have to cut off the exponent, I'm actually going to make a little box there. Okay, I'll just separate it. So 1/4 to the x, what's 1 times itself? 1. What's 4 times itself? 16. So that would be 16 down there. To the first power is just 1/4 itself, and then 4. And then the 0 power is 1. Now that +1 means you have to transform your x's, okay? So what's the, and we do the opposite with the x's. So +1, I need to -1. And I can forget about it. So it's 1, 0, -1, -2, -3. Now my x's are set. Now the outside operations, you have ×2 and -7. And you also have to do that to the asymptote as well, ×2 -7. So 1/16 times 2 minus 7 is -6 7/8. Remember, we won't end up graphing that. 1/4 times -2 minus 7 is -6 1/2. 1 times 2 minus 7 is -5. 4 times 2 minus 7 is 1. And 16 times 2 minus 7 is 25. Now don't forget the asymptote. 0 times 2 minus 7 is -7. Okay, now I want to start graphing here. Okay, I'd want to start this way. -3, 25. I'd have to go by 5's. 5, 10, 15, 20, 25. Now set up the asymptote. -7. So 5 and -7's right there. Okay, so all points will be on that side. Negative 2, 1. Remember, 1 is just a little ways up because we're going by 5s. Negative 1, negative 5, so that's down here, and then that's all that happens is I go up that way, but then here I just get infinitely closer to my asymptote. Okay, so domains all. The range, you're going to have y, negative 7, and you're above it, so it's greater than, wouldn't have an equals. Okay, next one. Remember, you're going to simplify this in a bit, so don't get all scared looking at it, okay? Asymptote y equals 0 to start with. So here's my x, and the base is 1/5. Now the power did keep going as -3, so I'll just put a box around that, okay? That's what we'll adjust the x's by, but first let's do the 1/5 to the x power. So what's 1 times itself? 1. What's 5 times itself? 25. So that would be 25. To the first is just 1/5, and then 5, and to the 0 is 1. Now you got to translate it, okay? You have to translate your x's by doing the opposite, negating the -3. So you'd add 3. So 5, 4, 3, 2, 1. Forget the -3. Now you also have a times -3 and a +2. You got to times -3 first and then +2. And you've also got to do it to the asymptote. So 1/25 times -3 plus 2 is 1 and 22 over 25. Not that I plan on graphing that. 1/5 times -3 plus 2 is 1 and 2/5. 1 times -3 plus 2 is -1. 5 times -3 plus 2 is -13. 25 times -3 plus 2 is -73. And don't forget to asymptote. 0 times -3 doesn't do anything, but +2 makes it 2. Okay, so we'd start graphing here first, where the fraction is not. Okay, 1 -73. Well, I'd have to go by tens. Down, 10, 20, 30, 40, 50, 60, 70, 73. If it's negative, you got to go down. Now set your asymptote at 2, but that's going to be barely up because remember we're going by tens, okay? Because that's where 2 would be about. Okay, then keep going. 2 -13. 10 right there. 3 -1, okay? So 3, -1 is just barely below the line because that is worth 10. Now you can just graph the exponent function, okay? So domains all, the range is y and 2. If you want to put a 2 right there, that's cool. You're below it, but you're not equal. Okay, 2y. Okay, asymptote always starts y equals 0. Okay, now, here's the x power, the base is 3, okay? Nothing else. And also maybe put a box around that, but for now we go 3 to the x. So 3 to the second's 9, and that would be 1/9. 3 to the first is 3, 1/3, and then we get 1. Now we have to transform our x's, we have to add 3. So it's because that exponent, -3. 4, 3, 2, 1. Now you also got a +4, but it's just +4. So that would be 13. 3 plus 4 is 7. 1 plus 4 is 5. 1/3 plus 4 is 4 1/3, and that's 4 1/9. Okay, and you also got to add 4 to the asymptote. Okay, so that would just make 4. Okay, so I'd start graphing here, 5, 13. It's a growth. Okay, growth I would graph here at the end. Okay, we got to go by 2's. So 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 12, 13. Now set your asymptote at 4, okay? So here's 4 right there. Okay, 4, 7, 1, 2, 3, 4, 2, 4, 6, 7, and then 3, 5. 1, 2, 3, 2, 4, 5. And then I pretty much, this has to be a sketch. It doesn't have to be exact. Okay? So domains all, the range you got y and 4. And it's all above it, so it's greater than. But don't put the line because it wouldn't be that. Okay, last one. Your parent function and the asymptote, domain and range down here, I forgot. So what's the parent function of this going to be? Well, here's the x power, the base is 2. So 2 to the x, and just put a little box with that plus 4. We'll minus 4 to all the x's once they're plugged in. So 2 to the x, that's the parent function. So 2 to the second is 4. 2 to the first is 2. 2 to the 0 is 1. And if we know that's 4, that's 1/4, and that's a half. The asymptote starts at 0. Okay, now you got that plus 4, so you have to translate your x's by minusing 4. You're trying to negate the plus 4. So it's going to be -2, -3, -4, -5, -6. Okay? Now, all of your y's have to be times -2 first and then plus 5. And that's no different with the asymptote. Now, a lot of people mess with their asymptote when they're doing the x. No, the asymptote's a y, okay, not an x. Again, I can't get that enough. When I have plus 4, I just minus 4 to the x's, not the asymptote. The asymptote's in terms of y, not x. Okay, so 4 times -2 plus 5 is -3. 2 times -2 plus 5 is 1. Next one, you're going to get 3, 4, and then 4.5. And then our asymptote is going to be 5. Okay, so I want to graph this one first. Okay, I don't want to start with the fraction. Okay, I want to go here. I can go by ones. After the first point's graph, set your asymptote at 5. So remember, you're going by ones because you can make that first point can be made by ones. 1, 2, 3, 4, 5. Okay, right there. And then I keep on graphing. -3, 1. -4, 3.